Thank you, Pinwest, for inviting me to give this talk. I feel really honored to be here. Myself is a technologist. I have hundreds of inventions on 5G, and my team has thousands of them. And we started this project a few years back, 5-6 years back. At that time, no one knows what 5G is. And 2019, this year, 5G is commercially rolled out globally. So it's really a proud moment for myself, for my company, and for my team. So what are the technologies that are in 5G? What are the technologies that are in your phone that Qualcomm provide the chip for? There's power management. Everyone wants long battery life. Clearly, there's imaging for your camera, and location services, facial recognition. Many technologies are in there, but today I'll focus on the radio part. So, as 5G, it will connect us to everything and connect us to the internet. So Qualcomm, as a company, we were founded by Irvin Jacobs 30 years ago. At that time, all the phones are analog phones, brick-sized analog phones. So the first innovation was digitized mobile communications. We converted analog communications to digital. And then secondly, we redefined computing. Almost 20 years ago, if you talk about computing, it means computer. It's not on your phone. But nowadays, most of the computation is happening on your phone. Of course, there's something happening in the cloud. So we actually redefined computing, moved from desktops to smartphones. And 5G is bringing another transformation. We're transforming all the industries that you can think of. I'll give you a few examples later. But how big is this transformation, and how big is the mobile industry? So typically in communication industry, because this is global, your phone needs to work in China, in US, in Africa. So typically we follow standards. These standards define the protocols so that wherever you go, your phone still works. So it's from 1980s to 90 to 2000 to 2010. Right now, there are 8 billion mobile connections. That's how big the market is right now in terms of mobile. And what 5G brings is we're going to connect all the fabrics in the society. So not only we will connect people, we will connect everything. And connectivity with 5G will become electricity. Just think of power. Everyone should take it for granted, and connectivity will be powering all the industry. As we have seen here, we have people, we have car, we have robots, we have stop signs, drones. All of them will have radio on them. So what I'm going to talk about are essentially two classes of communications, two classes of industries we're impacting. The first one is still mobile experience. This is what's in your pocket, what's on your phone. So for consumers, what 5G means is you will have more mobilized media and entertainment. You will have, for example, if you go to a venue, go to a concert, even if it's very congested, you will have this boundless experience. You will be not be limited by bandwidth. And we're also inventing this immersive experience with VRs, but more revolutionary was augmented reality. I think I'll spend a lot more time on that. So what is enough in terms of speed for our phone? I still remember I had a discussion in 2014 or 15 with another pioneers of 5G. The guy told me that infinite is the speed we're shooting for. What does it mean, infinite? He said when you access any content on your device, you're limited by the bandwidth of the silicon access. If 5G communications can provide the same speed at the speed you're accessing your memory, accessing your storage, then it's infinite. You cannot tell the difference between local content and remote content. So that's precisely what we're trying to do. So if you look at the speed, even the first generation 5G phones, we have 2 gigabits per second for wide area coverage, 5 gigabits per second for local hotspots. Those speeds are quite similar to the speed you're accessing the content on your phone already, locally. So that's sort of the revolution that we'll have for our next generation phones. But there's a second class of connectivity 5G is providing. This is expanding the mobile ecosystem to all the different industries. I'll give a few more details later. But you can see we have I don't know if I have a clicker here. Sorry, there's no. But on the top left, this is factory automation. And then you have autonomous cars. Although cars can drive by themselves right now, but there are so many challenges. Full automation will require a lot more information that 5G can help. And then you have remote medicine. You have precision agriculture. Energy, utility industry can also use this wide connectivity. For example, for smart grid, the requirement we have is saying that smart grid typically runs at power line 300 some hertz. So if you want to really control it, the latency you can have should be a fraction of a cycle. So that means on order milliseconds. How do you provide millisecond latency for smart grid of thousands of kilometers? So those are the challenges we're facing. Of course, you also have asset tracking and logistic and retail. So all these are the industry we're touching with 5G. So what are the key technologies in 5G? So what I showed you before are almost aspirational. I'm telling you we will impact these things, but what are fundamental technologies? Today I'm going to talk about maybe 4 or 5 of them. The first one is millimeter wave. Millimeter wave, I think by definition, it means the wavelength of the communication signal is on the order of a millimeter. So that's in actual implementation, it's about 30 gigahertz to 100 gigahertz. That's the range we're looking at. Currently, most of the phones in your pocket, they communicate around 1 or 2 gigahertz. So why do we go to such high frequency? Because we're running out of bandwidth. If you want gigabits per second type of communication link, you want the channel bandwidth, you want the spectrum to also be on the order of gigahertz. So when we go to higher frequency, there are very large amount of unharvested spectrum. So that's why we go to high frequency. But when we go to high frequency, there are a lot of technical challenges. For example, high frequency doesn't propagate very fast, very far. So you need the beamforming technology. And also, typically is based on line of sight. If it's blocked, what do you do? So you need a lot of repeater, and we call it IAB, integrated access backhaul technology. And how do you make it mobile? Because millimeter wave already exists. I don't know if you guys heard of WiGig. It's a type of IEEE technology for wireless docking. But the design is for tens of centimeters. It's for docking your laptop to a display. How can I extend it to hundreds of meters? So that's what we're doing in 5G, is we are essentially mine the resource at very high frequency and expand the bandwidth. So that's what millimeter wave is going to do for us. So millimeter wave, at this moment, we think still mostly the millimeter wave can be used for offloading hotspot, either outdoor hotspot or indoor hotspot. And after you offload the traffic, then you can use lower band spectrum to provide ubiquitous coverage. So you will see a lot of indoor application coming up, either for enterprise or venue or transportation hubs. These are the typical places you'll see millimeter wave. I think Verizon, AT&T, they have already rolled out millimeter wave in city centers and in transportation hubs. If you're lucky enough to have those phones, you can take a look. In my company, there are a few millimeter wave sites. It's all, download speed is on the order of gigabits per second. So it's pretty exciting to have millimeter wave. But another technology that we're focusing on is this industrial IoT. So you can see there are robots, there are sensors, there are head-mount displays. What we realize is in a factory, all these different nodes, sensors, actuators, they have very distinctive need for communications. So typically when we design communications, we just say how many megabits per second, how many gigabits per second. But here it's different. Not only we have megabits or gigabits per second of data rate, we have a latency requirement, 1 millisecond, because the control loop is running at 1,000 hertz. So latency has to be there. And also reliability. I cannot afford to fail. I cannot lose a packet. So the reliability in this case is 6 nines, 99.9999% accuracy has to be there. So these are very different communication protocols. So 5G is enabling this ultra-low latency and ultra-high reliability communications. So that's the second technology that I want to mention. And the third one, I think that Alan and Thomas both touched upon, is edge. So edge technology. What's happening is AI, everyone knows. AI can be run in the cloud. AI can also be run on your phone. Your phone is actually, for example, camera. Almost all the state-of-the-art cameras, as far as I know, have a lot of machine learning in it, has a lot of advanced AI algorithm. What 5G does is we provide this connectivity between your device and the servers, either deep in the cloud, over here, this is a traditional public cloud, or the edge cloud. These clouds don't sit hundreds of kilometers away. They sit in the communication network. So in communication network, we have something called CRAN, Cloud RAN. It has this remote unit and the central unit, where one central unit can drive hundreds of base stations. And there is essentially a data center in there for processing for communication protocols. But next to the data center, you can also install these edge servers. They're not only for communications, but for offloading the computation and for artificial intelligence. So 5G, what we provide is this connectivity allow you to seamlessly transfer content and processing between the edge server, deep cloud, and device. Another technology I want to talk about is IoT. So Internet of Things has been around for quite a few years. People talk about it. What 5G does is we make it massive. The amount of connectivity we can support with 5G network is 1 million devices per square kilometer. If you think about it, a square kilometer has 1 million square meters. So the connectivity we can support is every square meter you can have one link. That's how much capacity we can support. So these will allow you to do smart city or agriculture, long-range communications, also for energy efficiency. So these type of devices right now is commercially already available. What we're waiting for is for the deployments and wait for the new use cases to pick up. Lastly, I want to talk about this cellular vehicular communication. We already have autonomous car. What does this CV2X offer us? Actually, our autonomous car is not there yet. No one have the true autonomous car yet. Why? Why is that? Because there's not enough information on the car. What CV2X promised, if you get this modem, you get this radio in your car, the first benefit you will see is the infrastructure. On every stoplight, I can install a radio, the CV2X radio. This radio will tell you traffic information. Say, hey, I'm going to turn green in 20 seconds, or at the intersection, there's another car coming. So watch out for the blind spot. The next benefit you'll see is as more and more autonomous car, or the CV2X enabled car gets in the market, these cars can relay information. Not only between them, they can say, I want to change lane. So this intention sharing will make the safety a lot better. But also when there's no infrastructure, these cars can relay information. things you cannot see. The car in front of you will tell you, oh, there's an obstacle 200 meters ahead. So your car will get that information too. And not only on the car, our vision is these CV2X modem, these radios, will also be on your phone. Because as I'm showing here, actually this functionality is already integrated into Snapdragon. It's on your phone. Many of them already have this functionality. What this enables you to do is between car and the pedestrian and bikes, cars will see you. Cars can communicate with your phone. So if it sees you on the side of the street, it knows your intention, it will try to avoid you. Still, a lot of work needs to be done. A lot of machine learning algorithms need to be defined to take advantage of this information. But you already have the CV2X functionality in your 5G phone. So that will change our, in terms of safety, in terms of energy efficiency, it will significantly change our world. I'll save the last 2 slides of my talk to give more details about probably the most exciting use case in my mind. It's XR glasses. So these are glasses. You probably have, I don't know if you have heard of this North Focal smart glass. It's like the next generation of Google Glass. It's very sleek, just like the glasses some of you are wearing right now. And it has all this information, just like your smartwatch give you this information on your glass, and you can control them with a touchpad. But these XR glasses is take it to the next step. You will see these augmented virtual objects in your world. For example, if you're walking down the street, you can see this virtual billboard on the building. You will see traffic information. You will also be able to have hologram conference with other people who are wearing these glasses. These glasses can also be, put on with prescription glasses at, fit for each person. So those are the glasses we want. One thing on this glass that's obvious is it has a semi-transparent display. And also, it has at least, from my understanding, 5 cameras. Because you have regular cameras, you have depth sensing cameras, you have eye tracking cameras, and it has IMU to track the 6 DOF, 6 degree of freedom in terms of your translation movement and rotational movement, so that it can render all the objects in the real world. But how do we make it work? A glass of this kind of form factor have a peak thermal envelope of about 2 watts. Our phone, our VR goggles, big VR goggles, they can tolerate about 5 watts to 10 watts of processing power. But a glass of the form factor you want to wear at most can tolerate 2 watts. How do you have all these devices and have a vision? Just think of the resolution that you're seeing. It's much bigger than a PC. You can play a game on it, but the processing power that's required is way above the PC class. How do you do that? You will need to offload. You have essential on-device processing. That's very low latency. You have AI also in there. But for most of the bulky, heaviest processing, you have to offload to the edge cloud. Who connects you? 5G. So for this type of XR glasses to take off, we need all the partners to come in, from app developers, for OEM manufacturers, for the infra vendors, and for edge server providers. But 5G will be the missing piece. It's actually currently being invented to connect everything and allow this to come. Thank you.